A very good day to Doctor. My name is Solomon Gerard, number matrix CN210070. Today I'm going to talk about the experiment 2 about porosity and density of a material. I'm from group 7 and today's date is on 6th of July 2022. So the theory comes like this. Matter is anything that has mass and volume which occupies space, where porosity is the open space between grains and trapped in gains in a microstructure of a material. Also can be known as the amount of empty void in materials. Porosity can determine the properties of materials such as mechanical, chemical properties, and mechanical degradation of materials. In this determination of porosity and density of our specimen, we are using the Archimedes principle. And to obtain a porous material's density, we need to crush the materials into powder due to the small pores in the material that can penetrate the liquid. Next are the calculation methods or formula we used in this density and porosity calculation. So the porosity calculation, we have used the formula of weight of dry substance and times by weight of wet substance over weight of wet substance times with weight of suspended sample times with 100%, where the density are calculated using weight of dry substance over weight of wet substance times with suspended substance. So we can see here is the drawing of the weight and using electrical mass balance. Next are the equipment that are used, which is the beaker, Bunsen burner, crate, balance, glass rod, and the specimen that we used in this project is block A1, steel plate, glass, glaze tiles, refractory, and brick. Here we can see the arrangement of the apparatus. Next is the procedure used for metal and glass. Here we use the specimen of aluminium, metal, and glass, where assume the specimen's block as non-porous. First, we weight the block that is getting the value of 2 decimal places. Then tie the block with the thread and weight the sample with suspended in water. Take out the sample from the water and wait while it is suspended in air. Use the edge of the filter paper to dry the residual water on the surface before weighting. Take the weight of each specimen and fill up the information in the table. Next will be the ceramic specimen. In ceramic specimen, we use the glass tiles, refractory, and bricks as a specimen. So this specimen contains of closed and open pores. Only the volume of open pores is bound for direct measurement, whereby the air in the pores is replaced with water. For this experiment, the specimen use tiles and refractory and also brick. So first we record the weight of the dry specimen, then put the specimen into the water and make sure that it is suspended. The specimen is suspended in boiling water for approximately 10 minutes to allow the water to penetrate into the pores for the specimen. Take out the specimen from the boiling water and while it is suspended in water, record the weight of the specimen. Suspend the specimen in air and the residue water is removed using the edge of the filter paper. Record the weight of the specimen while it is suspended in air. So next we are going to see the result. Here is the result of the metal and glass and aluminium weighted. So here we can see the dry specimen suspended in water and suspended in air. Next will be the ceramic weight result, which uses the glass tiles, refractory, and bricks. So we can see the dry specimen, suspended specimen in water and air. Next will be the observation. In this experiment, we get the observation of the density, which the steel specimen has the highest density, while in ceramic, the brick specimen has the highest density, and the calculation is used in this formula as shown here. So we can see the result for each specimen after doing the calculation. Next will be the observation for porosity, where in porosity, the small space particles that has low percentage of porosity is steel. This is due to the compact of the particles tightly together, but the aluminium and refractory substance has high percentage porosity due to the more gap in the particles. Next will be our discussion of our project. In discussion, we get from this experiment is that the increase in density of the steel and glass specimens causing the decrease in the porosity of the specimen. But we can see in the ceramic specimen, the increase of porosity of the specimen causes the density to also increase. This is due to the arrangement of particles of each specimen are different because the steel and glass specimen particles are packed together while the particles in ceramic specimen are not. Other than that, other alternative method that can be replaced for the immersion method is the gas expansion method, which the air inside the material is sucked out using a vacuum blast tank. Not only that, hydrometer is the equipment that used to measure density, where it can partially submerge in liquid and the density can be measured when it stays in a certain height from the liquid. Finally, other method that can be determine the density of the powder specimen is using the formula by dividing the mass of the powder with the volume of the liquid using a powder container. So finally, we have come to the conclusion recommendation, where in conclusion of this experiment was a success. We as a team has learned that the porosity and density of a specimen, where we understand that porosity or white fraction is a measurement of white space in material, or also can be used the calculation of fraction of a volume of white divided with the total volume. Not only that, we also understand the meaning of density, which is the mass of a substance per volume. We as a team would recommend that the experiment should be taken in place as person to person or face to face, due to gain more experience and to avoid more parallax error during taking the result of each specimen. That's all. Thank you.